Hi children, in our today's class we will start a new chapter in physics. This is the third chapter of class 6th. First two chapter is what is physics and we have measurement, that is second chapter, and now we are going to study the third chapter, that is force and pressure. Right? See now children. First thing, what is force? We will take few examples and we try to explain this. In the first example, right, see children, what is force? Let us try to understand the topic of force with some examples. In first example, if you observe, two boys are pushing against the back of the bus, so that the bus is moving forward. Bus is moving forward and from back side the children are pushing. In the second example, a person is pulling the door open by grasping the handle. By holding the handle. He holds the handle and he is pulling. So in both these examples, one condition is pushing and one more is pulling. So what does it say? The boys are either pushing or pulling to move something, whether it is a bus or it may be a door or whatsoever. So either they are pulling or they are pushing. So force is defined as a push or a pull. In general, we can say force is one of the push or one of the pull, so that if you do this activity, the body should displace the position, its position should change. Then that is said to be a force. Next thing, when an object is in a state of rest or motion, suppose children, the object may be at rest or in motion, a physical cause is required to bring about a change in its state of rest or motion. Suppose you just think that this body is at rest now, right? And you consider one more scenario, the bus is moving. Okay, we have taken two conditions. One is a person is at rest on the bus stop, or a stone is in the rest position. A stone is in the rest position, that is position A. And we consider one more position, a bus is in motion. If you consider these two situations, one is at rest and one is in motion, bus is moving with constant speed. So in order to move a bus with different speed, maybe the speed may be increased or speed may be decreased. In order to do that, a physical cause is required. An external agent is necessary to do that, to bring that change. Even a stone is at rest at one particular point. In order to bring the change in that particular stone, someone has to take away or someone has to push it. Someone has to do some work on that. Okay, so either the body is at rest or the body is in motion. In order to bring change in that either bodies, the rest body or in motion body, we need some sort of force, right, about the change in state of motion. So like stopping the rolling ball, the ball is rolling now. So in order to roll a ball, we have to stop. In order to stop, we have to put some hand or leg. Otherwise, since it is rolling on the floor, it will have friction. Okay, the friction, that all thing we will learn later. Okay, in order to stop something, we have to apply a physical cause is necessary. That physical cause is nothing but force. So how we can define now force? Force can be defined as a cause. Defined as the cause which changes or tends to change the state of motion. That force may change the motion of a body or tends to change. Tends means try to change the position of the body. Either it may change or try to change. Okay, whatever it may be, state of rest or uniform motion, the direction of motion may change, shape may change, size may change. So whatever may be the change we expect, that is said to be a force. We go for the next concept. Types of forces. Forces have been classified into two types. One is contact force and non-contact force. When we said it as constant force, the force exerted by an object at the point of contact with the another object. Suppose I want to throw this pen. If I want to throw this pen, pen is one of the object, my hand is another object. I am applying force on this pen with the help of my hand. Here there are two forces. I hold this pen. The pen is in contact with my hand. So that is why it is said to be a contact force. Best example is pushing a car from backside in order to start a car. Kicking a ball, football, whatsoever. Kicking a ball is one more example. Okay, likewise we can say the constant contact force. One more is non-contact force. A force is said to be non-contact if the object exerts a force at a distance from the other object on which applied. I mean there will not be in contact, but that object will exert force. For example, if I leave this pen, what happens? It will definitely fall down. How it is falling down? That there is no contact between this pen and earth, but it will fall towards the earth. So that the force is here, the pen is falling without any contact. So such kind of forces we call it as non-contact force. For example, apple falling from the tree, the magnets will attract a small pins which is somewhat far away from the magnet. Okay, these are all come under non-contact force. Likewise we can define contact and non-contact force. Okay, in case of contact force, if you observe, it can be divided into two types. Not only two types, it can be divided into around, okay, we will see now. It can be divided into few types. See now, the first thing is muscular force or machine force, mechanical force. Muscular force means muscles, with the help of muscles we are doing. Mechanical force in the sense that is done by the machine whatsoever. The fan is rotating, it's a mechanical force. See now, force exerted by an object to make another object move is called mechanical force. Force exerted by one object, okay, to make another object to move is called mechanical force, or it is also called as it is also muscular force. See, muscular force in the sense, with the help of muscles, I am throwing a stone. Here my muscle is helping throw a stone. That is a muscular force. Right, see now. Movement of sailboat due to the mechanical force exerted by the wind. Wind helps a sailing boat to move. Right? Wind will, the direction of the wind, in the direction of wind the boat will move. There the wind is forcing the boat to move. Wind is helping as a mechanical force there. Second thing, closing or opening a door. So that is muscular force. With some person will hold the hold the handle and he will try to close it or he will try to hold it, open it. So that is a muscular force. And pushing a bicycle pedal. So through our legs, with the help of legs we are going to pedal. So there will be muscles in the legs that will help us to pedal. So these are all come under muscular force or mechanical force. And one more is contact force is frictional force. What does this frictional force? This force slows down the motion of a moving body. Okay, when try to move over the other body. When body is moving over another body, the frictional force come into takes place. See children, suppose there is a kid. A kid is pedaling on the road, cycle. He is pedaling the cycle on the road. When once he removes pedaling, once he stops pedaling, what happens? The cycle slowly, gradually slows down. Why the cycle is slowing down there? There is some force which is making the cycle to slow down. The cycle force is in one direction. So there is another force which exactly in opposite direction making the cycle to move slowly. Making it too slow. So there is some external force there. That force we call it as frictional force. This pedaling force is an applied force. One thing you remember that this frictional force is always in opposite direction to the motion of applied force. Remember that. Alright. Sliding the book on the surface of the table. If you throw the book will slide for some time and afterwards it will stop. There also frictional force arises. Right? Rolling a ball. If you roll a ball on the field, the ball will roll for few meters. After some time it will stop. Why? Because exactly in the direction opposite to the direction of the motion of a ball, there lies some force. In our friction chapter, we will study in detail, right? Just to know the example. Dragging a chair, sliding of the coin in the carom board, striker. Okay. So these are all come under frictional force. Next thing, non-contact force. Till now we have studied about the contact force. Now we go for non-contact force. Non-contact force can be classified into magnetic force, gravitational force and electric force. What is this magnetic force? The force exerted by two magnets or force exerted by magnet and magnetic material is called magnetic force. This is one of the kind of non-contact force. So if you place a magnet near steel pins, hairpin or iron particles, they will try to attract. Though they are not in contact, they are somewhat far away from each other, but they will try to attract. Right? So that is what we call it as magnetic force. A magnet attracts the iron pins like poles. Like means similar poles. Similar poles of the two bar magnets will repel. If there is north pole, they will try to move away. We are going to get the chapter some magnetic properties in this class only. There we can study in detail regarding magnetic. Right? Now go for gravitational force. See, the gravitational force, one thing is it is always attractive force. There is no repulsion in case of gravitational force. Whatever may be the body, if you throw up, it will definitely fall on the earth. The earth will attract that particular body. The earth attraction, we call it as gravity or gravitation. Okay, the force of attraction between the two objects due to their masses. Every body will have attraction with the another body. Right? Suppose if I am here, the pen is here, and there is somewhere in North India, there is one more stone or whatsoever may be the body, there will be the attractive force between this body and that body. You may ask me, why all the bodies are not attracting if there is attractive force. The thing is, one thing you remember children, weakest force in this universe is gravitational force. Which is the weakest force? Gravitational force is the weakest known force on this earth. That is why those two doesn't stick together. Right? So that is the reason. But there will be the attractive force definitely. Every object in our surroundings is attracted by the earth. Okay? This you should keep it in mind. Whether it is person, object, whatsoever. See children, while we are studying physics, if we consider object, a person is also object, a bird is also object, a chair is also object. So we don't consider living things and non-living things separately in terms of physics. Remember that. Next thing is electrostatic force. The force acting between electrically charged objects is called electrostatic force. What is charge, how the body is going to be charged, everything. For the best example is if you comb a dry hair and place a small pieces of paper and you try to place the comb near it, the pieces of paper will try to attract the comb. Even if you rub the balloon with your hair and or silk cloth and you hold it near the wall, it will try to attract. Okay, these are all come under electrostatic forces. One by one we will learn in detail everything children, there is no need to worry. Alright. Next thing is consequential force. There is one more force, that is consequential force. What is consequential force? These forces do not exist on their own. See children, these forces never exist on their own. Okay. However, they are called into play when force is applied on a given body. When you apply some sort of force on a body, then only a new force is going to be created there. That created force, we call it as consequential force. Best example is normal reaction force. I mean tension force, tension in the string, frictional force, till now we have discussed, that is also a consequential force. When a frictional force arises, when we try a body to move, when the body comes to motion, then friction arises. Okay, so that up till the body was at rest, there was no friction. When once the body starts motion, then the friction arises in the direction opposite to that of applied force. That force which have been arised, okay, that force we call it as consequential force. Or normal force is also a consequential force, normal reaction force. Next thing, a force is represented by two parameters, one is magnitude and one more is direction. So what is magnitude? Generally the force is, the SI unit of force is Newton, children. Suppose you just consider any of the force is 50 Newton. 50 Newton, 50, the number indicates the magnitude, right? 50 Newton in some particular direction, there may be east or west whatsoever, left, right, top, bottom, east, west, any of the direction. 50 Newton with direction, total considered as force. Here 50, the number indicates the magnitude and the direction is east, due to east, that indicates the direction. Okay, next, so the head of an arrow represented by the direction of force. In the head, you have written force, at the head you will put one arrow mark. Since force is a vector quantity, of course we shall slowly learn what is vector, what is scalar, everything, right? No, there is no need to worry now. Now we go for units of force. It has been divided into two systems, one is CGS system and one more is SI system. SI system and MKS system almost same. So in case of CGS system, the unit of force is dyne. What is the unit of force in CGS system? We call it as dyne. And in case of SI system, the unit of force is Newton. So what is the difference between dyne and Newton? Let us define. See, one dyne is the force required to accelerate a mass of 1 gram. So 1 gram mass of a body by 1 centimeter. By 1 centimeter. Suppose we have taken a 1 gram mass body. On that body, if you apply some force, so that it will try to move 1 centimeter with the application of the force that we applied. The force that which we applied at that particular instant of time is called 1 dyne. Similarly, what is the Newton? Newton is to accelerate a mass of 1 kg. Here we have considered 1 gram. In case of Newton, we consider 1 kg mass. When we apply force on 1 kg of mass, so that it should accelerate by 1 meter per second square. It should accelerate 1 meter. 1 kg of mass should move how much? 1 meter in second square, in 1 square of the second. That we call it as the definition of Newton. Right? The relation between the CGS unit and SI unit is, 1 Newton is equal to 10 to the power of 5 dyne. Now we shall try to derive what is 1 Newton is equal to 10 power 5 dyne. We know from the definition we know the definition of 1 Newton and 1 dyne. Till now we have discussed it, right? So what does 1 Newton say? Force required to accelerate a mass of 1 kg in 1 meter per second square. Okay, first we see Newton. Let us try to convert the Newton into CGS unit. Because the dyne is in CGS unit, let us try to convert them, both of them in one. So you just the dyne as it is, you try to convert this. 1 kg is equals to how much? 1000 grams. CGS means centimeter gram second. So the kg is converting into 1000 grams. Okay, next 1 meter. 1 meter is equals to how many centimeters? 100 centimeters. Then 1 meter per second square, which is equal to 100 centimeter per second square. That is 100 centimeter per second square. So 1 Newton is equals to mass into, I mean 1 kg into 1 meter, 1 centimeter per square. 1 kg is 1000 grams into, we have converted this into centimeters, 100 centimeter square, 1 followed by 5 zeros there, that is 1 lakh gram per centimeter cube. 1 lakh gram, so but 1 dyne is equals to 1 gram per centimeter cube. So 1 Newton is equals to 1 lakh dyne, because 1 dyne is 1 gram per centimeter cube. Here how much? 1 lakh centimeter cube, 1 lakh gram per centimeter cube. 1 lakh can be written as 10 to the power of 5. 1 followed by 5 zeros, so we have written 10 to the power of 5 dyne. So what is the relation between Newton and dyne? 1 Newton is equals to 10 to the power of 5 dynes. Keep it in mind. Next thing, measurement of force. How we measure the force? Spring balance is one of the instrument used to measure the mass of, measure the force, used to measure the force. Spring balance is of two types. One is compression spring balance and one more is expansion spring balance. What is the principle of compression spring balance? Spring gets compressed when a force acts on it. In some situations, when we apply force on a body, there will be the spring, that spring just compressed. The spring will be compressed. In some situations, the spring gets stretched or elongated. That elongated or stretched spring we call it as extension spring balance. If we put some sort of weight, the spring is going to be elongated. In some situation, if there is some sort of weight, if you put some sort of weight here, the spring get compressed. The compressed spring one we call it as compressed spring balance, and the extension elongated spring we call it as, when we apply some sort of weight on that, the spring is going to be elongated. Generally handling, when we hang, the hanging spring balance will elongate and there will be some sort of weight. So that one, if you put some sort of weight on that, the spring is going to be compressed. So that is compressed. So we will get two kinds of balances. Next one, action reaction force. So what is action, what is reaction? One thing remember children, when there is an application of force, the force does not exist on a single body. First thing you remember that. Force will never exert on single body. I mean the force never exert alone. In order, if you want to say there exists some sort of force, at least they should have two bodies. Okay, in that one will be action, the other will be reaction. But we cannot say definitely which is action, which is reaction. That is also you should remember that. We cannot say which one is action and which one is reaction. Suppose if you throw a ball on the wall, the ball has been moved and it hit the wall and come back. Ball has given some sort of force on the wall, simultaneously the wall has given some sort of force on the ball. There will be two forces there, equal and opposite direction. Since the ball is heavier, I mean stronger when compared to ball, the ball doesn't move, the ball will come back. But in those two things, one will be the action and other will be the reaction. Since those directions are in opposite, ball is weightless, so it will come back. It is coming back, ball has to go back in other direction, but it will not move because it is a stronger one. Okay, but the same force that have been that the ball has given to that wall also. So in those two things we consider one as action and one more as reaction. Remember that. Net effect of force. Two or more forces acting in the same direction. Suppose the applied force, if two people are applying some sort of force, if there is no force in other direction, and what happens here, the total resultant force will be increased. Suppose if the force exert on the same body in opposite directions, equal force, I am applying some sort of force in this particular direction and there is some other force which has in this particular direction. If both the forces are equal, then this body doesn't move. That force we call it as balanced force and that force will be always 0. 10 Newton one direction, 10 Newton in another direction. Though the net effect is 0 there. Okay, remember that. Next thing is, what are the differences between normal reaction and tension? Here you are going to get new words. These are also different kinds of force only, but it is very interesting, children. Try to listen now. It is the supported force exerted by the surface to support the weight of an object resting on it. Suppose I have kept a book on the table. The book will be there only. If there was no table, definitely the book will fall down because there will be the acceleration due to gravity, weight. It always acts perpendicular to the surface. So the weight is going to be act in downward direction as there is gravitational force. But there exists a normal reaction force when we keep a book on the table. That force will be in opposite direction, and this force will be equal to the weight that is giving in downward direction. These two are equal and opposite forces. And next one is tension force. It is a pulling force transmitted through string, rope, cable or any thread. For that there will be the tension. It is always along length of the string or rope. The best example is weight hanging from a rope. So in order to clear the concept of tension, I will give you an example. Here it is a beautiful example. I think you definitely understand what is tension. Suppose a person is pulling some box with the help of thread and person has applied some force towards him. Then what happens here? Let us see now. Object here, object we have considered three objects. One is rope, the other one is box, number 2, and the third one is hand. Okay, we have considered three situations here. Applied force, tension and direction. So if you know this concept, definitely you will get the clarity of tension. See now. Hands pulls the rope, right? Hand is pulling the rope here towards this direction, right? Hands pulls the rope, that is applied force. You just consider only hand now. Then tension, the other end pulls the rope. So when the hands pulls this rope in this particular direction, the tension will be created in this rope in the opposite direction. Okay, that is other end pulls the rope. So what will be the direction here? Opposite. Second case, box. On the box, what is there? Rope pulls the box. Who is pulling the box here? The rope is pulling the box. In which direction? In this particular direction, right? So tension will be in the same force and same direction, because box itself cannot pull the rope. Box is at rest position. Box is just doing what the rope activity is here is rope. So box is just kept quiet. So the forces will be in one particular direction, that is the direction of the rope that which the box is pulling. So same force and the direction will be the same. In case of rope, hand now. Third one. Rope pulls hand. Okay, so applied force is rope pulls hand, opposite of hand pulling. Hand is pulling in this direction, the rope will, because inside the rope there exists what is known as tension. Tension is going to be created. Tension is one kind of force which will be opposite to the direction of applied force as that of friction. Right? See now, the tension will be created in opposite direction here. So the direction relation will be opposite. That is why we have to apply large amount of force in order to pull the object and pull the rope there. So this is the concept. I think you understood, children. The physics will be very beautiful. If you really love my channel, love my class, you try to share for most as possible. Okay, thank you, children. We shall meet in the next class.